Naka-screen share ba? Okay. Okay, so we are now on the chapter 3, chemical equilibrium. No? So we are familiar with reactions that only go in one direction. No? Ibig sabihin, isang direction lang yung reaction. Bigay tayo example, the combustion of glucose in the presence of air in the atmosphere that will produce carbon dioxide and water molecules. So malalaman nyo that this is a one direction lang yung reaction na yan as indicated by the single-headed arrow. No? So ito yung single-headed arrow, it tells us that the reaction is just going to the product side, no? From reactant towards the product. No? And it makes sense naman. Kunwari, sunugin mo yung papel. So yung papel, maging carbon dioxide and water yan. So hindi agad-agad yun ma-reverse, no. If you want to do the reverse, then the plants have to do that, no. Yung plants siya yung gagawa ng reverse reaction for this one. Pero considering tayo ay nasa laboratory, sinunog mo yung papel, hindi na babalik yan sa original na paper molecules na yan, no? Sa sugar molecules ng papel. Okay? So that means there is just one direction for this reaction in our example, no? Okay. Pero merong reactions that happen in two directions, no? For example, yung ating water, our water dissociates into ions in such manner na yung water molecules nag-split yung hydronium ion and yung hydroxide, pero bumabalik din yan uli sa water molecules. Okay? So that can be kailan natin malalaman kung dalawang direction yung reaction? Just look at the arrow, no? So we have a two-headed arrow here. So one is pointing to the right, the other is pointing to the left. Okay. So that means some of the reactants convert into product. However, those products also go back sa reactant, no? So nagjo-join din sila para bumalik sa reactant, no? Whenever we have a system or whenever we have a chemical reaction that can occur in two directions, to the product or to the reactant, then we have what's called the chemical equilibrium. Okay, so ibig sabihin, if may double-headed arrow, we have a chemical equilibrium system. So ito yung ating topic ngayon. So dadaanan natin yung first 3 chapters nito and followed by the other 3 topics for the next meeting. So today we're going to focus on the equilibrium concept, the thermodynamics. Actually, hindi naman siya thermodynamics talaga. No? Yung idea lang about the equilibrium and how to solve basic equilibrium problems. Okay? So tatlo lang yung focus natin today. So again, as I told you, equilibrium reactions are reactions in which your reactants are converted to product, but at the same time, your products are being converted to the reactant. So, kumbaga, meron tayong dynamic process. No? So, dynamic because parehas yun nangyayari. So, this is the definition of the chemical equilibrium. No? So, chemical equilibrium is a state in a system at which the rates of forward and reverse reactions are equal. So that means, yung reactant na pupunta sa product and yung product bumabalik sa reactant. All happening at the same rate. No? Okay, so ibig sabihin balanced yung rate ng reactions natin in two directions. Yan na yan. Okay. Ano yung importance na to sa analytical chemistry? No? So, the importance of equilibrium in analytical chemistry is that we can actually quantify the amount of matter we have whenever we have equilibrium systems. And for us to calculate or to quantify the amount of substances in our equilibrium systems, we have to make use of the equilibrium constant. Okay. So equilibrium constant helps us to describe the ratio of the amounts of matter in the product and on the reactant side of your equilibrium system. So ito yung equation that relates the amount of the products with the amounts of the reactants. No? So mathematically speaking, equilibrium constant K is the concentration of your product species over the concentration of the reactant species. Suppose we have this dummy equation A plus B in equilibrium with C and D, wherein all the small texts are the coefficients. No, we can express the concentration of product as the molar concentration of C raised to its coefficient times the molar concentration of D raised to its coefficient. No? So again, paano yon? O yung mga product nyo, i-express nyo lang sila into molar concentration. So when you say molar concentration, square brackets yan. Okay. So yan, square bracket yan. Molar concentration of substance C, molar concentration of substance D. I-multiply mo sila. And then, what you're going to do with the coefficients is that you will make them as the exponent of your species, no? Gagawin mo silang exponent ng iyong species. For example, itong small letter C, that will be the exponent of substance C. Small letter D, that will be the exponent of substance D. Okay? Then, sa baba naman, sa reactants nyo, you have the reactants, no? So, ganun din. So, concentration of A times concentration of B. The coefficients are going to be our exponents, no? So, ayan, small letter A, magiging exponent yan ni A, and yung B, magiging exponent yan ni B. Okay? So, let's try to work on some examples on writing equilibrium constants, no? But before tayo mag-proceed, mayroon tayong disclaimer lang, no? So, suppose we have this equation. We only write the substances in aqueous phase and gaseous phase, no? Sa equilibrium constant. That means if you have liquids and solids, you are not going to write them in the K, no? Hindi mo siya susulat sa equilibrium constant. The reason why will be discussed on the next chapter, no? Sa chapter 4. Okay? Sa ngayon, basta solid, basta liquid, wag isusulat sa equilibrium constant. Suppose natin, yung letter A, solid siya. Hindi mo siya isusulat dito. Buburahin mo yan. Kunwari, yung letter D, ito ay liquid. Buburahin mo yung letter D. Only those who are in aqueous and gaseous phases must be written in the equilibrium constant. Okay? So let's have some examples here. So we have here the equilibrium expression or the equilibrium equation for the auto-ionization of water. No? Auto-ionization kasi yung water, bigla-bigla siya nag-ionize. No? Automatic yan. Okay. So this is the equation that we have. Let us try to express the equilibrium constant for this equation. So we write K equals the concentration of product over the concentration of your reactant. Okay? So on the numerator, andun yung products mo. So what are our products? H plus and OH minus. Since they are both in aqueous phase, then we can write it sa K. Okay? So kapag aqueous pati gas, yun lang yung pwede isulat sa K. Pero kapag yan ay liquid and solid, hindi siya isusulat. Okay? So let's write the products, no? So H plus is aqueous, hence we should write it. Okay? So we write the square bracket of H plus. Again, kapag square bracket, it indicates molar concentration. Then, yung katabi niya, OH, you multiply it dito sa H+. Okay? Our coefficients is 1. So, ibig sabihin, wag na natin isulat yung 1 na exponent kasi matic naman yun. Okay? So, that is how we write the equilibrium expression for the numerator part. How about the denominator? Okay, so on the denominator, we have H2O, okay, which is in liquid form. So ano sabi natin? Kapag liquid, hindi isusulat. So basically, 1 lang yung nasa baba. Okay. Hindi siya 0 kasi anything divided by 0 is undefined. No? So 1 lang pag ganyan. So that means overall, the K expression for the dissociation of water can be written as the H plus concentration times the OH minus concentration. Ayan yung kanyang equilibrium equation. Or yan yung equilibrium constant expression. Okay, ganun lang. Also, since we write the molar concentrations, no, kailangan i-indicate natin anong uri ng K yan. No? May dalawa kasing uri ng K. May isang Kc, may isang Kp. Pag sinabing Kc, that is the equilibrium constant in which naka-concentration units ang ating substances. Naka-concentration units. So, in our case, naka-concentration unit yung H plus and OH minus, so we write it as Kc. Okay? K na concentration. Equilibrium constant na naka-concentration. How about Kp? Okay? So, Kp, ito naman kapag naka-pressure units yan. Okay? So, saan ginagamit yung pressure units? Di sa gas, no? Kasi remember, aqueous and gases, yung pwede natin isulat. So kapag gas isusulat mo, pwedeng concentration, pwedeng pressure. Pero kapag aqueous yung isusulat mo, concentration lang yung pwede sa kanya. Kasi walang pressure yung aqueous systems. No? Yung gas meron. Okay? So kapag aqueous yung nasa equation mo, Kc lang ang meron ka. Pero kapag gases ang nasa equation mo, you have both Kc and Kp. Okay, so let's have some more examples. Okay, so we have dinitrogen tetroxide in equilibrium with 2 moles of nitrogen dioxide. So both of our species are in the gas phase, no? So that means we can write both Kp and Kc expression for the two substances. Okay? So let's try to write the Kc, no? So again, Kc product over reactant. So what is our chemical species sa products? NO2. Okay, so you write square bracket NO2 and then may coefficients siya na 2. You're going to write the 2 as the exponent. So square mo yan. Okay? O, punta naman tayo sa baba. O, on the denominator, you are going to write the N2O4. Okay, so square bracket N2O4. Ayan. Yan na yan. Yan na yung Kc. How about Kp? So in writing Kp, that is similar with Kc. However, instead of using square bracket, we will use letter P. No? P meaning pressure. Kasi kapag square bracket, concentration yun eh. So square bracket, concentration, letter P, pressure. Okay? So in terms of pressure, the equilibrium constant can be written as the pressure of NO2 squared, still same as Kc, no? Squared pa rin yan. Sa baba, that will be the pressure of N2O4. Okay? So, ganun. So, again, kapag Kc, naka-molar concentration ang units sa amounts ng gases. Kapag Kp, naka-atmosphere units ang pressure ng dalawang gases. Okay, ito question ko. Parehas kaya sila ng value? So, ang sagot natin doon ay hindi. Bakit? Kasi concentration is different with the pressure. Okay? So, that means iba yung Kc natin sa Kp. Baka kasi mamaya isipin nyo parehas yan. No? No. Because iba yung units for the concentration at iba yung units for the pressure. However, we can use the gas laws to derive the relationship between Kc and Kp. Okay? Although mamaya na yan. Okay? So, ganun lang yung idea. Pag gases, may Kc ka, may Kp ka. Also, magkaiba yung values nila. So, iba yung value ng Kc sa value ng Kp. But there is an equation that relates the two using gas laws. Okay? Okay? So, yan. Pag aqueous, Kc lang meron. Kapag gaseous, may Kc ka, may Kp ka rin. Okay? So, let's try some examples here. Practice tayo sa pagsulat ng equilibrium constant. No? So, we have these three equations here. So, let's try to write the equilibrium constant expression. So, let's have letter A. We have hydrofluoric acid plus water producing hydronium ion and fluoride ions. Okay? Sulat natin. Ano yung magagawa natin dyan? Kc lang ba? Kp or Kp lang? So, since ang ating substances ay aqueous, yan ay Kc lang. By the way, yung liquid, wag papansinin. Okay? So, imagine nyo yung liquid wala dyan. Okay? Bakit? Next meeting yan. I mean, next chapter yon. Doon natin malalaman kung bakit. Okay. So, let's write the Kc for letter A. So, on the numerator, we are going to write the concentrations of the product side. So, that will be the concentration of hydronium ion times the concentration of fluoride ions. Yun na yun. Sa denominator tayo. So, ano meron sa denominator? HF and H2O. However, H2O is in liquid form, so set aside mo yan. Only HF will be written. Okay? So, ganun lang. Yun na yun. Okay? Let's have letter B. So, for the second equation, we have gaseous phases. So, kapag gaseous phase yan, ano meron tayo? We both have Kc and Kp. Okay? So again, kapag gas, Kc, Kp ang meron. Kapag aqueous, Kc lang. So let's write the Kc first for letter B. So ibig sabihin niyang concentration. Sa numerator, ano kaya yon? That will be NO2, nitrogen dioxide. Squared. Bakit squared? Because yung coefficient gagawing exponent. How about the denominator? Yung nasa reactant yung ilalagay natin. So, lagay natin, so let's have here NO squared times oxygen gas. Ayan, tapos na. Yan na yun. Yan na yun. So, yun na yung Kc for letter B. Again, product over reactant, yung coefficients gagawing exponent. Yun lang. Gawin naman natin yung Kp for letter B. Okay, so kapag Kp instead of using square brackets, we use letter P to indicate pressure. Okay, so that will be the pressure of NO2 squared all divided by the pressure of NO squared times ganito na lang times the pressure of oxygen gas. 'Di ba madali lang, ganito lang excuse me, ganito lang talaga siya. Well, nothing more, nothing less, yan na yan. How about letter C? How about letter C? How are we going to write the equilibrium expression for this one? Okay, so lahat yan naka-aqueous except for liquid water. So that means we only have Kc for this equation. So let's write Kc equals to numerator, denominator. Numerator, yung product. Denominator, yung reactant. No? So on the numerator, we have the CH3COO, C2H5. Okay, so sulat natin yan. CH3COO, C2H5. How about water? Are we going to write it down? Hindi. Bakit? Kasi yan ay liquid. No? Kanina ko pa siya ina-emphasize. Kapag solid liquid, wag isusulat. Aqueous and gas lang ang pwede. Okay? Kung tanong nyo, bakit? Next chapter yon. Okay? So, yan. So, sa numerator, CH3COO, C2H5 lang. On the denominator, you have your reactants. So, parehas yan aqueous. So, both must appear in the K expression. So, we have CH3COOH times the ethanol, C2H5OH. Okay, so that will be our equilibrium expressions for the three equations. No? Again, emphasize ko lang, kapag yan ay gaseous, we can write both Kc and Kp. However, if yan ay aqueous, we can only write the Kc. Okay, so yun lang. Punta na tayo dito. So, di ba sabi ko kanina that for gaseous species, we can write Kc and Kp. No? So, we know that Kc is the equilibrium constant expression in terms of concentration, while Kp is the equilibrium constant expression in terms of the pressure. So, since iisang molecules lang naman yung pinag-uusapan natin, then the two must be related. No? Yung Kp and yung Kc, dapat related sila to one another. Okay? Their relationship is shown as this. No? This formula. Kp equals Kc times RT delta N gas. No? So if you want to check the derivation, I actually did that last year dun sa video ko ng Basic Analytical Chemistry sa YouTube. No? So may playlist doon na general equilibrium. Ito din yung dinidiscuss ko doon. So yun. So pwede nyo makita doon yung derivation. However, we have limited time kasi for the lecture. So yan na yung equation. Okay. So yan. So ito yung equation that gagamitin natin in order to get the relationship between Kp and Kc. That means if given ang Kc, you can solve for Kp and vice versa. Okay? So, describe natin ano yung mga terms na kailangan natin sa equation. So, obviously, you have your Kp, the equilibrium constant in terms of pressure. You have the Kc, the equilibrium constant in terms of concentration. The R, which is your gas constant. Anong gas constant yon? Yung 0.08206 liter atmosphere per mole Kelvin. However, when writing equilibrium expressions, wala tayong ilalagay na units. So basically, yung gas constants, hindi natin ilalagay yung hindi natin ilalagay yung units, just the number, 0.08206. Walang unit dito ha. So yung mga tinatamad magsulat ng units, safe kayo dito. Kasi wala talagang unit dito. Letter T, that is the temperature. And the temperature must be converted in Kelvin values. No? So, kailangan naka-Kelvin. Kasi gas constant mo, naka-Kelvin yan eh. And then you have this delta N gas. So what is delta N gas? No? So expand natin. Delta N gas is the difference of the gas sa product minus the gas sa reactant. Okay? So, kuha tayong example para mas makita nyo. Suppose we have equation letter B. Identify the delta N gas. Ba tayo maging steady nito? Ayan. So, for letter B, let us identify the delta N gas. So, that is product minus reactant. No? The moles of gas in the product minus the moles of gas in the reactant side. So, how many moles of gas do we have in the product side? Tignan mo. Bilangin natin. Dalawa. Dalawa lang. So, 2 moles of gas in the products. How about reactants? So, for the reactant side, we have 2 moles of gas for NO and 1 mole of gas for oxygen. 2 plus 1, 3. No? So, that will be product minus reactant. 2 minus 3. So delta N gas will be negative 1. And that difference will be your exponent sa ating equation na ito. Okay? So ganun lang. Ayun na yan. So tapos na tayo sa first half ng ating session for today. So ano yung mga kailangan natin i-remember bago tayo mag-start with answering questions, no? So, ano kailangan natin i-remember sa ngayon? Equilibrium constants are mathematical equation that we can use, no, to describe the relative amounts of your substances in equilibrium system. So, yung sinabi ko na yon, ang equation nun ay ito. Ito yung katumbas niya na equation. Ito yung ratio ng amounts ng substances, no, products over reactants, no. For this equation, we can write the K as this one. Concentration on C raised to its coefficient, concentration of D raised to its coefficient, all divided by the reactants, which is concentration of A raised to its coefficient, and the concentration of B raised to its coefficient. Okay. For in writing equilibrium constant, we must not write liquids and solids. No? Hindi mo sila isusulat. No? Instead, you will write those who are in aqueous and the gaseous phase only. So kapag aqueous phase, you only have Kc. Pag gaseous phase, you have both Kc and Kp. So ano itsura ng Kc? May square bracket. Ano itsura ng Kp? May letter P instead of the square bracket. So for gaseous equations, Kp and Kc are both related by the equation Kp equals Kc RT raised to delta N gas. So kunwari, given yung Kc, hanapin mo yung Kp, solve it using this equation, and vice versa. So let's try to answer some basic equilibrium questions na. Medyo marami to kaya yan, mamamaster natin to siguro today. Okay. Madali lang to sa ngayon. Okay? So let's answer this first question. The equilibrium constant for the decomposition of phosphorus pentachloride to phosphorus trichloride and molecular chlorine is found to be 1.05 at 250 degrees Celsius. If the equilibrium partial pressure of PCl5 and PCl3 are 0.973 and 0.548 atm respectively, what is the equilibrium partial pressure of Cl2? Okay. So, every time na nasa equilibrium topic tayo, ang una nyong gagawin is to write the equilibrium constant. Okay? Ayan, lobat yung aking battery. So, yun yung una nyong gagawin. Whenever you encounter equilibrium questions, the first thing you have to do is to write the equilibrium constant expression. Kaso dalawa yon, Kp, Kc. Ano pipiliin mo? Look at your given values. Sabi dyan, Kp. Tapos ano pa? Partial pressure. So, ibig sabihin yan, Kp yung gagamitin mo. Sasabihin naman kung Kc yan or concentration na. So, ganun. So, in our case, Kp ang kailangan. So, gawin muna natin yung equilibrium expression for this equation. Ito. So, equilibrium constant is equal to the pressure of the gas in the product over the pressure of the gas in the reactant. No? So for the product side, we have PCl3 and Cl2. So let's write that. Pressure of PCl3 times the pressure of Cl2. So pressure nito, pressure nito. Then for the reactant side, you have the PCl5. So sulat mo yun sa baba. So yan yung una nyong gagawin. Write first the K expression. Ang ginagawa nga ng classmates ko dati dito, di bali na walang sagot, basta may K constant. Kasi 1 point yon sa amin dati. wala siyang sinagot pero may ganito. 1 point yon. Kaso ngayon hindi tayo ganun eh. Hindi tayo face to face eh. So basta ganun na, every time na makakita kayo ng ganyan, sulat mo na yung K. No? I forgot Kp yan. Okay. So what's next? No? Basahin uli natin yung problem. The equilibrium constant is found to be 105. So ibig sabihin itong value na to ay 105. Yan yung ratio nitong lahat. Pag ito pinag-divide mo, minultiply mo, ito yung katumbas niya, 105. If the equilibrium partial pressure of PCl5 and PCl3 are this and that, so ibig sabihin yung PCl5, ito yung kanyang pressure, 0.973 atm. And si PCl3, ito yung kanyang pressure, 0.548 atm. Hanapin natin ito, yung PCl2. So in order for us to solve for the PCl2, we have to rewrite our equation. Okay? So algebra na tayo. Sulat ko dito. Okay, so mag-algebra na tayo. So we have PCl3, PCl2 divided by PCl5. Okay? So since we are looking for this one, ano sabi ng algebra teacher natin? When you are looking for one unknown variable, make sure to, sabi nga ng classmate ko dito, evacuate all the other terms. No? That means you have to transpose all the other terms besides your unknown. Okay? Ibig sabihin ito, kailangan mo ilipat sa kabila. Ito, ilipat mo sa kabila. Okay? So we can do that by cross multiplication. Okay? So magme-mental cross multiplication na lang tayo. Paano yon? Yung numerator mapupunta sa baba, yung denominator mapupunta sa taas. Kaya nga cross multiplication, saliwaan. Okay? So that you will be left with PCl2. Okay? Ito, algebra lang yan ha. Kaya nyo na yan. So let's solve for the PCl2. Okay, ano uli ginawa natin? So ito, cross-multiply mo yun sa kabila. So itong denominator, mapupunta sa numerator. Ito, pag cross-multiply mo yan, mapupunta siya sa denominator sa kabila. So let us rewrite the equation. So we have PCl2 equal to Kp times PCl5 Okay? Pressure of PCl5. And then sa baba, yung pressure ng PCl3. Okay? So, yan. So, KP, PCl5. So, look, ito nasa baba ngayon. Pag cross-multiply mo yon, mapupunta siya sa numerator. Ito, nasa taas. Pag cross-multiply mo yon, mapupunta siya sa denominator. Okay? And then, what's left for us to do is to plug in the numbers and solve for the PCl2. So, KP is 105. How about PCl5? That is 0. Nawala. 0.973 ATM. Pero sabi ko kanina, when solving for equilibrium constants, do not write the unit. No, wag mo muna isulat yung units. Sa dulo na. Sa dulo mo na ilagay. Okay? Kasi ito yung thing with equilibrium constants. The unit will never cancel out, no? So, ganun kasi talaga. Thermodynamics yan eh. Thermodynamics yung principle nito. So, sa thermodynamics, di talaga kami gumagamit ng units doon. Numbers lang. Okay. So, yan. So, kapag ilalagay mo yung pressure, wag mo na ilagay yung unit, just the number. And then, sa PCl3, that will be 0.548. Zoom nyo na lang dito sa baba yung screen nyo. Okay, so let's solve for the pressure of Cl2. Calculate lang yan. 105.973.548. So in 2 decimal places, our final answer will be 1.86 ATM. Sa dulo mo na isusulat yung pressure unit. Okay. Automatic po na kapag pressure, ang gamit ay ATM. So, ganun lang. Kunwari, concentration yung hinahanap o automatic, molarity yon. Okay. Pag nilagay mo sa dulo yon, molarity dapat. Pag pressure, ATM. Kunwari, sir, paano po? Kunwari, ito, torr. Kunwari, yan ay torr. Iko-convert mo pa yan. Okay. So, ko-convert mo siya sa ATM before mo ipasok sa equation. Okay. So, this divided by 760, no, to get the ATM, kunwari. So, magbibigay naman ako ng worksheets na para may guide kayo sa pagsagot-sagot, especially pagdating ng midterm, no. Malapit na eh, no. Parang happy-happy lang tayo lately, tas midterm na, no? Okay, so yan. If you have questions, you can raise them, ha. Chat lang kayo dyan sa chat box natin. Tuloy-tuloy lang ako kasi ang dami nang i-cover sa lecture. Okay, so let's have this second problem. The equilibrium constant for the reaction, ayan, is 158 at 1000 Kelvin. Calculate the pressure of oxygen if the pressure of nitrogen dioxide is 0.4 atm and the pressure of nitrous oxide is 0.27 atm. Ano sabi ko? Basta equilibrium problem, isulat agad yung Kp or Kc. However, in this problem, specified na pressure ang gagamitin natin. So, we write the Kp. Sulat natin yung Kp. So, that will be numerator 2NO. Okay, so pressure of nitrous oxide squared. Ano pa yung katabi niya? Oxygen gas. So, that will be the pressure of oxygen gas divided by the reactant, nitrogen dioxide. So, pressure of nitrogen dioxide squared. No? So, yan yung K expression natin. Ano sabi sa problem? We solved for pressure of oxygen. Ito yung hinahanap. So, hanapin natin yan. Ayan na siya. Gawa tayo ng equation para ma-solve natin yan. So, again, cross multiplication to kasi may katabi ito na ibang terms. So, itong nasa denominator, cross multiply natin para malipat siya. Itong nasa numerator, cross multiply natin para malipat siya. Di ko na ipapakita yung actual derivation na. 'Di ba dati ginagawa ko, ginaganon ko pa, so magka-cancel. Ngayon hindi na. Kasi mas maganda kung mas mabilis na tayo mag-solve ngayon. Kasi wala na, ulit-ulit na 'to eh. Hanggang dulo na yung equilibrium natin. Okay, so let us write the equation for the pressure of oxygen gas. Okay, so yung Kp nasa numerator, yung PnO2 mapupunta sa taas. Yan, naka-square yan. And then, yung PnO, mapupunta naman sa baba. Lagyan ko lang ng parenthesis para hindi siya, para malinis tignan. Okay. So since we have the expression in solving for PO2, what's left for us is to plug in all the numbers. No? Plug in muna lahat ng numbers. Kp is 158. PnO2 is 0.4 squared. And PnO is 0.270. 0.27 squared. Again, walang unit na pag nagsosolve. Sa dulo mo na siya isusulat. Solve natin yan. 158.4 squared divided by 0.27 squared. So the final answer will be 346.78 atm. Laki, no? Laki ng pressure ng oxygen. Feeling ko nga nagkamali ako ng type dyan eh. Pero yaman. Okay. Hindi ko kasi malaman kung saan ba may maling type. Pero anyway, mathematically speaking, ganyan naman yung pag-solve niyan. So yan. Yan na yan. Okay, so again, madali lang, no? Basic lang, no? Cross multiplication, then yun. Yun na yun. Okay. So, sa ngayon, ganun pa lang siya kadali. No? So, hopefully, yung quiz, yung part 1 ng quiz nyo dito, ma-perfect nyo, no? Kasi equilibrium constants lang yan eh. Yung second part kasi nito, may quadratic equation na, may trinomial na, no? So, yan, good luck, no? Don't worry, I will teach you the shortcuts. Pwede rin i-calculate yan eh. Tuturo ko sa inyo yung calculator shortcut. Let's have this problem. Methanol is manufactured industrially by the reaction carbon monoxide plus 2 moles of hydrogen gas in equilibrium with methanol. The equilibrium constant Kc for the reaction is 10.5 at 220 degrees Celsius. What is the value of Kp at this temperature? Okay. So, ito na yung relationship ng Kc and Kp. So, given yung Kc, hanapin yung Kp. Anong equation gagamitin? Kp equals Kc parenthesis RT raised to delta N gas. Okay? So, ayan. Zoom natin. So, hinahanap yung Kp. So, okay na yung equation na yan. Magpa-plug in na lang tayo. So, Kc is 10.5. R is gas constant 0.08206. Do not write the unit. Basta alam mo, liter atmosphere per mole Kelvin yan. Temperature is in Kelvin. So, ito convert mo yan to Kelvin. Ano yun? 220 plus 273.15 lang yan. So that will be 493.15. Tama ba? 493, okay. So 493.15 Kelvin. Okay, so how about delta N gas? So for delta N gas, we have to look at the equation. So how many moles of gas in the product side? So we have 1. Isang methanol lang. How about the reactant side? We have 1 for the carbon monoxide and 2 for the hydrogen. 1 plus 2 is 3. Okay, so to get delta N gas, that is product minus reactant. 1 minus 3, negative 2. Okay, so we plug it here. Siya yung magiging exponent ng ating quantity. And we solve for the Kp. Pakipindot na lang sa calcu. Okay, so in 2 decimal places, our final answer is 6.41 times 10 raised to negative 3. So that is the value of Kp. So again, look, magkaiba yung Kp and Kc. However, they still have relationship, kasi we have the same equation naman. We have the same substances, kaya related sila sa isa't isa. Ayan. Nagpo-pause ako talaga by the end of the slide para mag-screenshot yung mga gusto mag-screenshot. Kapag di kayo napag-screenshot, antayin nyo na lang to sa YouTube mamaya. Okay. So let's try this one. Isa pang item. So consider the reaction at 395 Kelvin. We have this substance decomposing into ammonia and hydrogen sulfide. The pressure of each gas is 0.265 atm. Calculate Kp and Kc. Sige. Paano yan? Sabi ko sa inyo, pag nakakita ng equilibrium equation, isulat agad ang K. Kaso ano yung susulat ko? Anong K? Tignan mo yung ibang given. Anong given? Temperature, pati pressure. May pressure kang given. So, you have to write the Kp first. Tignan mo muna yung given, ha. Mamaya, sinulat mo na yung Kc. Di mo naman pala magagamit, na. So, Kp muna kasi pressure yung given. So, what is the Kp for this equation? That will be the pressure of ammonia times the pressure of hydrogen sulfide. How about the reactant? Susulat ko ba yan? Sagot ay hindi. No? So, hindi ko siya susulat because siya ay solid. No? Remember, only aqueous and gaseous phases are ought to be written in the K. Yung solids and liquids, hindi sila isusulat. Okay? So, yan na yung Kp natin. Basahin natin uli yung problem. The partial pressure of each gas is 0.265. Okay? So, ano yung ibig sabihin ng each? Ibig sabihin, yung pressure nito at yung pressure nito ay ito. So, ayan. So, that means, imumultiply lang natin yung same number, 5. Imumultiply lang yun natin yung number twice, no? 0.265. So we will get Kp, and that is 0.07. Tama ba pagkakaalala ko? Check ko nga. Okay, that's 0.07 in 2 decimal places. How about Kc? Paano natin kukunin yung Kc? Use the formula. Okay, so ano yung formula natin? Kp equals Kc RT delta N gas. We are solving for Kc. That means we have to cross multiply this entire term. So, i-cross multiply natin yan sa kabila. So, mapupunta yan sa denominator. Okay? So, yan. So, that will be our working equation. What's left for us is to plug in all the numbers that we have now. So, KB is 0.07. R is 0.08206. Temperature is 395. Delta N gas. Alamin natin delta N gas. So that is product minus reactant. How many moles of gas do we have in the product side? Isa, dalawa. So 2 moles of gas in the product side. How about the reactant side? Wala. So wala tayong gas sa reactant side. So 2 minus 0 is 2. Square mo yan. Okay, so yan, solve na natin, Casey. Hindi ko na kaya i-mental yan. Point. Okay, so the answer in 2 decimal places would be 666 times 10 negative 5. Okay, so 6.66 times 10 raised to negative 5. So that will be the Kc value. Ayan, so yan na yung yan na yung mga basic equilibrium questions. Actually, meron pa mamaya na. Sige. Let's proceed na. So let's go back to equilibrium constants. So, yung equilibrium constants natin, it depends on your equation, on how you write your equation. So, kunwari, binaliktad mo yung equation, your equilibrium constant will change. Kunwari, times 2 mo yung equation, your equilibrium constant will also change. So, every time nakalikutin mo yung equation mo, may corresponding changes yan. Okay. So, let's take a look at some examples ng operations with equilibrium constant. Number 1, when writing the equilibrium reaction in the opposite direction, the equilibrium constant becomes the reciprocal of the original constant. Ano meaning nun? Sulat natin. So we have equation A and B. Okay, so yan yung equation A, ito yung equation B. Ano mapapansin natin is that the substances are flipped. Naka-flip yung equation. Okay, so naka-flip yung equation. Sulat natin yung K for A and yung K for the B. A. Yung concentration na lang for now. Concentration tayo. For A, that will be NO2 squared divided by N2O4. No, yun lang. Then for B, that will be sa numerator, yung N2O4. Sa denominator, yung NO2 squared. So what can you notice, no? Sa equilibrium constant natin, as we flip our equation, nag-flip din yung numerator and yung denominator. So whenever your numerator and denominator flips, we call that the reciprocal. So that means KB is the reciprocal of KA. So yan. So whenever we flip the equation, we get the reciprocal. Binaliktad mo lang, nagbaliktad din yung fraction. Pag nagbaliktad ng fraction, tawag doon reciprocal. So yan. So yan yung first rule natin. Second rule. Okay. The value of K depends on how the equilibrium is balanced. No? So let's have this example here. So on equation A, ano meron tayo sa A? The coefficients are integers. No? So ibig sabihin ng integer ay whole number. On equation B, we have fractional coefficients. So ibig sabihin, decimal yan. In this case, 1/2 na. Ito, dinivide lang by 2. So, what will be the effect nun sa ating equilibrium constant? No? So, let us write the K for A and B para makita natin. Galaw ng galaw to ah. Ayan. Ayan. Ay. Okay, susulat ko lang to. Ay, ba yan? Mamadali. Wait lang ha, ulitin ko. Mamadali eh. Wait lang ha. Ito. Okay, so B, sa A, that will be square of NO2. Square. Sa baba will be N2O4. Sa B, that will be NO2. And sa baba, that will be N2O4 raised to 1/2. Ano mapapansin nyo? If you could still remember your pre-calculus na actually algebra lang yan. At can you notice? Syempre, sasabihin ko rin naman, no? So, ano yung manonotice natin dito? Is that, kapag yung iyong equation, dinivide mo by 2, your K, your new K becomes the square root of the original. Okay? Ibig sabihin nun, yung original in square root mo. Kapag dinivide mo yung equation by 2. Tignan natin, ha? Square root nyo yung KA. Kunin natin square root niyan. So, pag square root mo yan, NO2 squared, square root mo yan, anong matitira? NO2 na lang. N2O4 squared, ano yung matitira doon? Raised to 1/2. Okay? So, basically, if you divide your equation by 2, the K becomes the square root of the original. No? What if naman i-times 2 ko yan? No, kunwari, letter C. Times 2 ko yan. Kunwari, i-times 2 ko yan. What will happen to the K? So what happens to the K is that it becomes the square, no, of the original. Okay. So kunwari ito, i-times 2 ko to. Ito na yon. Tignan mo, kapag times 2 ko to, what will happen to the equilibrium constant? It becomes the square, no, of the original. This squared is this. This squared is this. No? So, ganun nangyayari. So, depending on how you balance the equation, you can either get a square root, cube root, or square or cube of your original K value. Okay? So, ibig sabihin nun, iba-iba yung K depending on how you balance the equation. Kung naka-flip yan, kung yan ay naka-square, times 2, naka-divide by 2, times 3, divide by 3. So for every operations na gagawin mo sa iyong equation, may corresponding changes yon sa equilibrium constant. Okay? So again, kapag in-square mo yan, kapag times 2 mo to, magiging square. Pag times 3 mo to, magiging cube. Pag dinivide mo to sa 2, magiging square root. Pag dinivide mo to sa 3, magiging cube root. And so on and so forth. Okay? So, pabago-bago yung value ng K depending on the equation. Okay, and last one. So, last one will be this one. Equilibrium constants are multiplied when you combine the reaction. So, when you say combine the reaction, pagsasamahin mo yung dalawang equation. Okay, so we have this equation here. A plus 2B in equilibrium with C. And the second equation will be C in equilibrium with D and E. Okay? So, kunin natin yung overall sum ng equation na to. So, pagsama-samahin natin. Pangit ng equilibrium ko. Yan. So reactant side, we have A, 2B, and C. On the product side, I have C, D, and 3E. Whenever you see similar species on both sides of the equation, you can cancel them out. So again, kapag may similar species, ika-cancel. So our overall equation will be A plus 2B in equilibrium with D plus 3E. Okay? Ano mangyayari sa K nun? Pag pinagsama mo daw, sabi niya, yung K overall will be the product of the two K's. No? So, yan yung product ng dalawang K. Tignan natin, totoo ba yun? Dapat kung ano yung K na makuha natin, pag pinag-multiply mo to, it should represent this equation. Tignan natin. So, sabi natin K is equals to K1, K2. Let us check. Ano yung K1? Ito yan. So, nasa numerator yung C, sa denominator yung A, and B square. Yung K2, ano meron? Yung D and E nasa numerator. D, E. Yung C nasa denominator. And tignan nyo, yung C, parehas sila magka-cancel out. No? So that the overall K will be D E cubed over A tapos B squared. Okay? So ito, this final K value, this represents this equation. Tignan nyo yung mga nasa product, D and E, nasa numerator. Yung 3, naging exponent. Okay? Ito, tignan nyo yung nasa reactant, A, B, the square. Yung 2 ng B, square doon. No? So, ibig sabihin, whenever you combine equations, you just basically multiply the 2K values. No? Okay? So, yun lang. So, in summary, the concentration of reacting species in condensed phases, phases yan dapat, are in molarity. In gaseous phase, the concentration can be expressed in molarity or in atmospheres. No? So, ibig sabihin nun, kapag aqueous, molarity ang units. Kapag gas, ang units ay molarity or atmospheres. So that's why Kc lang kapag condensed phase or aqueous. Kapag gaseous phase, meron kang Kc and Kp at the same time. Second, the concentration of pure solids, pure liquids, and solvents do not appear in the equilibrium constant expression. The reason why is makukwento next chapter. Okay, so doon natin makikita bakit hindi pwede siya isulat. Number 3, equilibrium constant are always dimensionless. When you say dimensionless, it doesn't have any units at all. Okay, yung K value, wala talagang unit yon. Only the pressure and the concentration has. No? Kaya whenever we are using K, hindi tayo naglalagay ng value. Sa dulo na tayo naglalagay ng units. No? And lastly, in quoting the value of equilibrium constant, the corresponding balance equation and the temperature must be written also. Okay. So depending on how you balance the equation, there is a corresponding value for K kasi, di ba? Example, binaliktad mo, reciprocal yon. Pag times 2 mo, magiging square yon. Pag dinivide mo by 2, magiging square root yon. So you have to write the equation together with the K value. And also yung temperature, important din. Important din, no? Bakit? Paano? Naaalala nyo pa naman siguro to, no? Yung Kp equals Kc RT delta N gas. So that means their values are dependent on the temperature. Ano pa? Yung Arrhenius equation noong senior high nyo, K is equals to A exponential negative energy of activation RT. So this Arrhenius equation tells us that the constant of equilibrium is proportional with the temperature, no? So nagbabago sila. Kung nakalimutan nyo na yan, okay lang. Hindi naman natin gagamitin to eh. Senior high pa to na for sure. Okay, so yung punto ko lang dito is that K differs at different temperature. Okay, so yan. Last part na tayo ng lesson natin for today. No? Daming sinasolve agad, no? Ganun talaga. No choice tayo. Okay. Predicting the direction of the reaction. Okay, so you can actually use the concentration, the equilibrium constant expression to determine whether the reaction will go to the product side and or to the reactant side, no? Saan to ginagamit, no? So ginagamit to, for example, ng mga biochemists, no, in regulating the metabolic pathways. For example, yung body natin, ano nangyayari kapag mababa na yung sugar level? Okay, the body activates the gluconeogenesis process wherein your fats are being converted to sugars, no? So that magko-continue ang metabolism natin. Kunwari naman, no, sobrang daming sugar, what will your body do? Your body will convert the sugars into fats, no? So may store yun sa ating tiyan, no? So ganun yung nangyayari. So with the equilibrium constant, we can actually tell whether the reaction will proceed to the product side or to the reactant side, no? Yun yung ginagamit ng mga biochemists in order to manage the metabolic processes sa katawan, no? To maintain balance, no? So sa analytical chemistry, ganun din ginagamit natin, no? Ganun din ginagawa dito. So we can tell whether magpo-produce ba yan ng product, magpo-produce yan ng reactant, or nasa equilibrium na siya. Okay? So for us to predict where the reaction is going, I will introduce you sa kapatid ni K, which is the Q, no? Reaction quotient, no? Magkapatid yan, no? Parang veil balir yan, no? Okay? So si K, this is the equilibrium constant. And yung value niyan, that means siya ay yung equilibrium. Pag sinabing equilibrium, yan yung balance, no? Yan ay yung lowest energy. So yun yung balance. No? Yung Q, ito yung reaction quotient, no? So mapapansin mo yung reaction quotient that has a similar formula with K. However, may subtle difference lang, yung letter I. Yung letter I, that means yun yung initial na value ng ratio na yan. Okay. So yan yung initial value ng concentrations. No? Tapos, ang gagawin mo, kunwari, given yung K, tapos given yung mga concentrations initially, you solve for Q. Then after that, you compare the Q with K. Okay? By comparing Q and K, you can predict where the reaction is going. Okay? So I use the number line, no, to visualize the direction of the reaction. So kunwari ito. If your Q is less than the K, then sabi nun, towards the product side, yung pag-move ng reaction. It will produce products, no? So, paano ko makakabisado yan? Ganito, I create number line. In the middle, I have my K. So, itong blue circles na yan yung K natin. Yung orange circles, yun yung Q. Okay? So, ginagawa ko, I create a number line. In the middle, I mark my K. Then, sa number line, hahanapin ko what is the value of Q. If Q is less than the K, so gagawin ng system mo is pupunta siya towards the K. So, anong arrow yung drawing ko? Papunta sa right side. Ibig sabihin, the system will go towards the product side to achieve equilibrium. Okay? To achieve balance. So again, ulitin ko lang. Kapag yung Q maliit sa K, yung point ng Q pupunta to the right para makuha yung K. Para mapunta siya sa K. Okay. So, ganun yung mangyayari. Your system will proceed to produce products. No? Yun yung direction ng reaction, going to the product side. What if naman yung Q sobra sa K, no? Mas malaki yung value ng Q kaysa sa K. Aatras yung reaction mo kasi lumagpas siya eh. Aatras siya. Anong arrow yung drawing ko? To the left. So kapag to the left yan, going to the reactant side yon. Okay? So ganun lang yung aking mnemonic dito. Ang ginagawa ko kasi nung college ako, ito lang kinakabisado ko kasi napagbabaliktad ko ito pati ito, no. Then later on naisip ko, ba't di na lang ako mag-number line? So sa number line, pwede mo pagawa ng arrow. So pag andito yung Q, andun yung K, punta ka sa right. Ibig sabihin, papunta sa product. Kapag andito yung Q, andito yung K, aatras yan. So going to the left or towards the reactant. But if your Q and K are equal, then balance na yan. Wala nang mangyayari sa reaction. At peace na yan. Okay, so let's answer the last two problems na involve itong predicting the direction of reaction. Last two items tayo. Okay, so number 1. At the start of the reaction, there are 0.351 moles of nitrogen gas, 3.62 times 10 raised to negative 2 moles of hydrogen gas, and 7.51 times 10 raised to negative 4 moles of ammonia in a 3.75 liter vessel at 375 degrees Celsius. If the equilibrium constant Kc is 1.2, predict the net reaction at equilibrium. Ano sabi? Tagalogin. Given yung moles ng nitrogen, hydrogen, ammonia sa ganitong dami ng vessel, ganitong volume ng vessel, hanapin mo ang direksyon ng reaction. Ayun lang yung sabi dyan in Tagalog. So, how are we going to solve for this problem? In order for us to determine the direction of reaction, you must compare Q with the K. Okay? So, gawin natin Q. Since KC given sa atin, edi QC yung gagamitin natin. No? Okay, so QC is similar with KC lang. Okay? Concentration ng products initially, concentration ng reactants initially. So QC, ito. So that will be the concentration of products squared over the concentration of reactants. However, sabi natin, kapag Q, initial yon. So, lagyan nyo ng small letter I sa baba. Just to remind you na reaction quotient yan. Okay? So, ibig sabihin yan, initial, before ma-achieve yung balance. Okay? So, ngayon, yan na yung Q natin. Ano susunod mong gagawin? Dapat magpa-plug in ka na ng numbers, no? But the problem is we are given yung moles ng substance. Ano ba dapat yung ilalagay natin dito? Dapat ay concentration. Okay. So since concentration ang hanap natin, can we determine the concentration of our substances? Anyone? Pwede ba natin malaman yung concentration nila from the given? Ano kailangan ko gawin upang malaman ang concentration? Any guess? Ako na rin sasagot. Ayan. Sinacharge ko rin kasi yung pencil. Okay. So, paano mo malalaman yung concentration? That will be the moles of your substance divided by the volume. Diba? Concentration, molarity, moles per volume yun, diba? So, that means you divide the moles by the volume. Okay? So, ganun gagawin natin. Ayan, so plug in natin yung mga numbers dito. So for ammonia, ano yung moles niya? 7.51 times 10 raised to negative 4. Ano yung volume ng vessel? 3.75. Okay. So, bakit dito ko na dinivide, no? Para yung calculator na yung bahala, no? Kasi kapag sinolve mo yan manually, pag sinolve mo separately yung concentration nila, ang problema doon is baka mag-round off tayo masyado. Nawala na yung digits natin, no? Dahil sa pag-round off, round off. So, i-plug in mo na lang yung moles and yung volume. So, dividing moles by the volume, you get molarity for ammonia. O, hindi lang ammonia. Kunin natin kay nitrogen gas. That will be 0.351 moles divided by the volume, 375. And yung kay hydrogen gas, 3.67. Okay, negative 2 yun. Divided by 3.75. Then cube. Okay. So let's solve for QC. Alamin si QC. Pakipindot na lang sa calcu. Okay, so QC is equal to, in two decimal places, 0.46 now. So that is the value of QC. Yan na yan. Yan yung QC. Tapos na ba yung problem? Hindi pa. Ano yung sabi sa problem? We have to determine the direction of the reaction. So, ano yung technique ko doon? Gawa kayo number line. So, in the middle, you have your KC, which is 1.2. Okay, so kung ito yung 1.2, asan yung 0.46? Hindi, nasa left nun. Okay. Okay. So, since ang ating QC ay nasa left side ng KC, in order to achieve balance, your QC must move to the right, no? So it has to move to the right to achieve balance. Therefore, the reaction will proceed towards the product. So it will proceed towards the product kasi mas maraming reactant kaysa sa product. Tignan nyo yung concentration, oh. Ito, 0.51. Ito, negative 4. So, mas marami talagang reactant kaysa sa product. So, in order for your system to achieve balance, itutulak niya yung ibang molecules para gumawa ng product until reach niya yung balance. No? So, that's how we predict the direction of the reaction. Solve for QC, compare it with KC, and then arrow-arrow na lang. To the left, to the right, yan. May corresponding meaning yan. So kapag to the right, it will proceed towards the product. Pag to the left yung arrow, it will proceed towards reactant side. Okay? So yan yung pagdetermine ng direction ng reaction. Next one. Last one na to. Sabi malapit na kayo mag-rest. Ako rin. Kapagod yung solving, no? Parang iniisip mo pa lang siya, oh my God, no? Pero imagine nyo na lang, umpisa pa lang yan, no? Mamaya may quadratic na tayo, di ba? Next meeting na yung mga yan. Kaya nyo yan. Algebra lang yan. Tsaka may calculator naman. Tuturo ko yung technique. Ito. Second item, last item na sasagutan natin today. The equilibrium constant Kc for the formation of nitrosyl chloride from nitric oxide and molecular chlorine is 6.5 times 10 raised to 4 at 35 degrees Celsius. In a certain experiment, 2 moles, 2 times 10 raised to negative 2 moles of nitrous oxide, 8.3 times 10 raised to negative 3 moles of chlorine gas, and 6.8 moles of nitrosyl chloride are mixed in a 2-liter flask. In which direction will the system proceed to reach equilibrium? Ang tanong lang dyan, to the left, to the right. Naka-close pala yung window. So, ang tanong lang dyan, to the left, to the right, yung pagpunta ng reaction. Alamin natin. So, let's solve. Ano gagawin ko? QC muna. Kasi KC yung given na eh. I will solve for QC. So, QC, that will be equal to products over reactants. So, NOCl squared. Nagulo yung sulat. So, NOCl squared sa product side. Sa reactant side, you have your NO and your Cl2. Ano susunod? Ang susunod ay plug in mo na yung concentrations. Okay, so let's plug in the concentration for NOCl. That will be, sana yung NOCl? 6.8 moles of NOCl. Divide mo yan sa volume ng flask, 2 liters, to get molarity. Okay, so again, moles divided by volume to get molarity. So yan yung molarity ng NOCl. How about NO? NO, that will give me 2 times 10 raised to negative 2. Okay. Divided by 2 liters squared. Then chlorine gas will be 8.3 times 10 negative 3 divided by 2. Ayan. So we solved for QC. Type ko lang to. Okay. So ang sagot natin ay sandamukal na numbers. I-scientific notation natin. So that will be 2.79 times 10 raised to 1, 2, 3, 4, 5, 6, 7. So this is the value of QC. 2.79 times 10 raised to 7. Laki, no? So, in order for us to determine the direction of reaction, gawa kayo number line, KC sa gitna, which is 6.5 times 10 raised to 4. Asan si Q? Since ang Q natin ay raised to 7, di lagpas-lagpas yun sa lagpas-lagpas yun sa K. So ito yung QC. So andun na siya, ayun na siya. So in order to achieve equilibrium or in order to achieve balance, how will your reaction proceed, no? Paano siya gagalaw? To the left, to the right. Siyempre, to the left, no? Kasi andun yung KC sa left eh. So your reaction will proceed towards reactant side na. The reaction will proceed towards reactants. So, yan. So yung reaction, it will proceed toward reactant. It means that it will convert the products back to the reactants. Kasi sobra-sobra yung products. Tignan nyo, ilang moles yan, no? 3.4 molar. Laki ng 3.4 molar concentration. So, gagawin ng system para maging balance siya in terms of the reactants. It co-convert niya yung NOCl back to the two molecules, no, until they achieve the balance. Okay. So, yan. That is how we predict the direction of the reaction. All this info ay necessary para sa mga susunod nating i-discuss, especially when we create the ice table. Okay, so next meeting, we are going to solve for the equilibrium calculations na. Okay. So, kung naalala nyo pa to sa senior high school nyo, good. Kung hindi na, okay lang. No? So, yan. So, that will be all for today's discussion. If you have questions, you can raise them. Pero if okay na kayo, then we're good to go na. Okay? So, again, over the weekend, I will upload some activity worksheets with solution. So, I want you to practice those items, no? Para kapag nag-quiz, kaya nyo na, no? And magagamit nyo rin yon for your midterm exams, no? Okay. Malapit na kasi mag-midterm, kaya tutulungan ko kayo mag-review with the help of those worksheets, no? Okay, so yan. Hopefully, gamitin nyo yung mga worksheets na gagawin ko, ha? Okay, so I will also give you a copy doon sa laboratory. Sa laboratory kasi, ganito ginagawa namin. Pakita ko sa inyo. I don't know kung ano yung approach sa lab sa inyo, pero sa aking class, syempre, yung mga former students ko, kilala ako. Pag calculations, nag-enjoy ako, no? Kasi I can place missing variables sa problem. So, kung ganito rin yung style ng laboratory nyo, then pwede nyo magamit yung aking mga materials. Although kapag hindi, edi okay lang. Additional learnings. No? So, bibigyan ko rin kayong copy ng worksheets dito. Okay? So, ayan. Study well. Malapit na ang midterms. And as I told you noong first class, mahirap ang anakem, pero manageable. No? Kaya yan. Okay? So, that will be all for today. So, I will see you again next meeting, next Friday. By the way, reminder, Thursday walang pasok dahil EDSA. So, give yourself a break. Mag-review na lang kayo that time. Okay? Bye-bye and ingat na. Nasa YouTube tong recording ng class discussion natin. Okay?